Hey, party people. People who love to party. It's me, Mr. Beal, coming to you today to talk to you about solving absolute value equations. This time, not necessarily with a graph. All right, let's take a look at what we're going to be working on. Bam. Now, you may be looking at this like, Mr. Beal, I definitely know how to do this problem. I feel like I've even seen it before. Yeah, that's good. I'm sure you have. What I've got to do is teach you how to fill in this part right here. Since I know you know how to do this, you know how to break it up into two things. We're going to graph that side and this side and then see where they meet. So let's go. We've got x minus 4. That's going to move this right 4. 1, 2, 3, 4. Ding, right there. And then since there's nothing in front, we're going up 1 and over 1 in both directions. Then we'll make ourselves as straight a line as we can so that we can see where the line is going to touch the graph. And then g of x is equal to 7. We're going to go 1, 2, 3, 4, 5, 6, 7. Then we're going to go against that axis. That's the quick way to graph these. Oh, yeah. Remember, g of x is just fancy y. Ooh, what? Uh-oh. Ran into a problem with my graph. It's like I know this point. This point appears to be, and I quote, -3, 7. But where the bleep is that? Now, this is where solving it without a graph comes in handy. And before we do that, we have to know a little bit more about an equation like this. So we're going to consult our friend Rando. Bing! Rando's random tips. So think about it this way. If you had x was equal to 5, or I should say the absolute value of x is equal to 5, what would x have to be, huh? Think, write something down, do it right now. You wrote down 5, didn't you? I agree. But also -5 would work because the absolute value of -5 is 5. So there's two answers for this thing. Well, what if I set it equal to 3? What if the absolute value of x is equal to 3? What could possibly work for an answer for x? Oh, 3, you say. I agree. But what else? -3, indeed. So then the same thing must be true for 10. It's got to be 10 and -10. Ooh, look how fast it just jumped to it. And then absolute value of x is equal to -2. That must be 2 and -2, right? Or -2 and 2. No, that makes no sense. If I put 2 in here, the absolute value of 2 is 2, not -2. If I put -2 in there, the absolute value of -2 is 2. I will never get this right here. Never. Nothing. Explosion. There we go. Thank you for that tip, Rando. Ding. So as I look at this thing, I know I should be getting 2 answers for it. And it's just like we set up with the other ones. If I had the absolute value of x is equal to 5, x was 5 or -5. In this case, my stuff on the inside is either 7 or -7. And you see, once I've broken it up into the two pieces, it doesn't have the absolute value signs anymore. We got it. +4 and +4. X is equal to 11. Ooh, I'm pretty sure that's where that was. That was supposed to be an 11. And over here, +4 and +4. X is equal to -3. There's the -3. So what I'd like you to do is take some time, take a little bit. And now that you've seen them, which do you prefer and why? Go ahead and pause the video, write it out. This is a preference. I could not possibly answer that for you. And if you don't answer it, I will tell my TA to mark down your paper. Oh, wait, you're not going to turn this in. Oh, guess if you don't answer it, you're just a chump. All right, moving on. So let's solve this thing graphically. Here's the broken up graphical parts. Got -4. That's 1, 2, 3, 4. At least one of you is screaming to me right now. Mr. Beal, no, dude. No. Shh. And I've got x, or the absolute value of x plus 5. 1, 2, 3, 4, 5. And then up 1 and over 1 for Evertron. And now you're screaming even louder. Mr. Beal doesn't shh. There we go. All graphed up. Now, your complaints of Mr. Beal, they don't touch. I know. So there's no solution. No solution. So how could we possibly do that out here? Well, we cannot have an absolute value sign equal a negative number. There's no way. You're always going to get no solution with that. There's no number that we could plug in there that would turn it into a negative. Nothing. Because absolute value always spits out positives. Okay. How about this right here? Je suis explosion. Numbers on the outside have to be cleared using inverse operations before you split the problem when you solve algebraically, but not for graphs. So check this out. We don't have to change anything if we want to graph this. It's very convenient. I can make this f of x is equal to the absolute value of x minus 1 minus 8. And g of x is equal to negative 4. Now at least one person is screaming to themselves right now, it's not going to work. It's not going to work. Chill out. 1, 2, 3, 4. Let's do the work. And then let the evidence determine whether we scream or not. And now this one, it looks like this one would be right 1 and down 8. So right 1, 1, 2, 3, 4, 5, 6, 7, 8. And there's nothing out there, so that's just an up 1 over 1, both sides. Let's go some more. It looks like if you were screaming earlier, you should have been quiet. Your foolish screams have availed you not at all. Looks like we've got answers at -3, -4, and looks like that's 5, -4. 1, 2, 3, 4, 5. Yeah, looks like it does it. So how do we do that without having to graph it? Because see how you started screaming a second there? Like there was no reason for that. This thing ended up dipping under that thing. But right now we can't split it because that's the negative. Not only can we not split it because it's a negative, we have to clear this thing first. I only want there to be an absolute value sign on the side, and then I split it. There shouldn't be anything else outside. So plus 8, plus 8. Now you can see it's not a negative out there that equals an absolute value. We can definitely do this. Split them up. X minus 1 is equal to 4. X minus 1 is equal to -4. Add 1, add 1. X equals 5. Oh, that's what we got right here. Plus 1, plus 1. X is equal to -3. Oh, ooh la la. Ah, oui, oui. Thing with an or in between them. Those are your two answers. Here, I'll give you a couple more examples. And specifically, we're going to do these examples because they are absolutely ripe for not graphing, which is what we're trying to do. We're trying to build this up without having to graph. And the reason is, normally we don't have things attached to our x inside of some absolute value signs. Like normally that would be on the outside. Look at both of them. They're so messy. So rather than try to graph those crazy things, we're just going to solve them. And the first thing we got to do is we got to get it so that it's just absolute value signs equals something else. So in this case, you're looking at that -3 and you're like, you got to get +3 plus 3. You end up with the absolute value of 2x minus 6 is equal to 7. And now we're going to split. We've got 2x minus 6 is equal to 7, and 2x minus 6 is equal to -7. We're going to do identical work on both sides, but get different answers for each piece. +6 plus 6. Divide by 2, divide by 2. 13 over 2, or 6.5. +6 plus 6. 2x is equal to -1. Divide by 2, divide by 2. X is equal to negative 1/2. There you go. If I were to say which one I like better, I'd have to say the algebraic way. And the reason why is I'd say because it's faster. Okay, now out here, oh poop. How do we get rid of that 1/4? It's on the outside. It can't stay there. Times by 4. 4 times a fourth is just 1. That means this is just 5x minus 1 absolute value signs because we don't have to write that 1 on the outside. Is equal to 12 because 1 times anything is just itself. Split them. That's what destroys the absolute value sign now. I've got 5x minus 1 is equal to 12, and 5x minus 1 is equal to negative 12. Identical work, plus 1, plus 1, plus 1, plus 1. Different answers. 5x is equal to 13. 5x is equal to negative 11. Divide by 5, divide by 5, divide by 5, divide by 5. X equals 13/5 or negative 11/5. Man, I hope I did that right. It feels like I did that right. Yeah, I'm good. All right. What I want you to do is before you get to the individual practice, which is just further along down the bottom of this page, I want you to try these with the video. Should have been working with me anyway, but seriously, try these. I'm going to stop my sharing. I'm going to pause it, and then I'll be right back. All right, let's do this. Checking your work, making sure that all your work is right. Ooh, let's move this over, move this over, move this over. Got about all we can get there. Sweet. So you're starting with your plus 5. You divide by negative 2, and then you're split. Then you solve each of those pieces by minusing negative 1. Next has got to be 0 or negative 2. Over here, you start with your subtracting 2 from both sides of that equal sign. You then times by 3 to get rid of the third. Then you finally, now that it's clear, you get to split. And from the splits, you get negative 2/3 or negative 8/3. There you go, guys. I wish you the best of luck on your work because you got plenty to do. I think there's about 8 or 10 problems that I left for you. Good luck. Hey, as always, stay safe. World crazy.